Beyond the reaches of our eyes, beyond the limits of the telescopes of the past, lies a realm of space and time so distant, it almost feels like an impossible frontier. Yet, within that frontier lies the key to understanding everything: our origins, our place in the cosmos, and the very nature of the universe itself. At the dawn of the universe, the cosmos was born in a fiery burst of energy, an explosion known as the Big Bang. From that singular event, all matter, all energy, and all the fundamental forces of nature began to emerge. For a long time, the universe existed as an empty, dark expanse, a canvas waiting for the first brushstrokes. In the aftermath of the Big Bang, the universe was a hot soup of gas and particles, but it wasn't until hundreds of millions of years later that the first sparks of light began to form. These sparks of light were the first stars, igniting in the darkness and marking the birth of galaxies. This moment, known as the cosmic dawn, is one of the most pivotal points in the history of the universe. It's the moment when darkness gave way to light, when the raw materials of the cosmos came together to create the galaxies that would eventually evolve into the magnificent structures we see today. Vast collections of stars, nebulae, and galaxies interacting with one another in a dance that has spanned billions of years. But these early galaxies, where the universe was still in its infancy, are no longer visible to the naked eye. The light from these galaxies has been stretched and altered by the expansion of the universe. In fact, much of the light from the first galaxies is now in the infrared part of the spectrum, far beyond what our human eyes can perceive. To see them, to understand them, we need a telescope capable of reaching into the depths of space, a tool that can detect the faintest light from the earliest moments of our universe. That tool is the James Webb Space Telescope. This is not just another space telescope. Webb is a revolutionary leap forward, designed to unlock the most profound mysteries of our universe. Developed by NASA in partnership with the European Space Agency, ESA, and the Canadian Space Agency, CSA, Webb is the most powerful and ambitious space telescope ever created. It is our time machine, our cosmic explorer, and our most advanced scientific tool. Launched in December 2021, Webb's mission is simple in its goal but profound in its potential: to look back in time to the very beginning of galaxies. It is capable of observing the universe as it was over 13 billion years ago, providing a view of the first galaxies that formed long after the Big Bang. Webb's instruments are finely tuned to capture infrared light. This is crucial, as it allows Webb to peer through cosmic dust clouds and detect light from objects far beyond what was previously possible. With its massive 6.5-meter primary mirror and advanced infrared cameras, Webb can capture galaxies that are so far away that their light has traveled for more than 13 billion years to reach us. Webb can now see galaxies as they were when the universe was in its infancy: small, faint, and radically different from the galaxies we observe today. But Webb's infrared capabilities are more than just a technical feat. They are the key to unlocking the hidden chapters of our universe's history. The light from these distant galaxies has been stretched, or redshifted, over billions of years, transforming it into infrared light. Webb's precision instruments can capture this light and allow scientists to reverse the cosmic stretching, to essentially peer into the past and witness the birth of galaxies. This process, observing the infrared light from the distant universe, allows us to see beyond the limits of space and time. Webb's unique position at the second Lagrange point, nearly 1.5 million kilometers from Earth, allows it to avoid the heat and interference of our planet, ensuring the clearest, most accurate observations of distant galaxies. Webb's instruments, such as the near-infrared camera, NIR cam, and the mid-infrared instrument, MIRI, are specifically designed to study light that has been stretched by the expanding universe, revealing the faintest of galaxies and even tracing their evolution across time. As Webb captures the first light from these early galaxies, it helps scientists trace their origins and evolution, unlocking the mysteries of how the first stars ignited, how the first galaxies formed, and how the elements we are made of, hydrogen, helium, and carbon, came to be. What Webb is revealing to us is far more than just images from a distant past. With every new discovery, scientists are uncovering the mechanics of galaxy formation. They are witnessing the violent and beautiful processes that formed the first stars and the earliest supermassive black holes. Webb spectrometers not only capture the light, but also break it down into its components, revealing the chemical makeup of these distant galaxies, showing us how the raw elements of the universe came together to form the stars, planets, and life we know today. As we look deeper into space, we are also looking deeper into time. Webb's data will allow us to observe the most distant objects we've ever seen, and in doing so, it will help us answer questions we've pondered for centuries. How did the first galaxies form? How did they evolve over time? What role did black holes play in shaping the galaxies around them? What can the first galaxies teach us about the future of our own galaxy, the Milky Way? Each new image from Webb is a breathtaking revelation. Far from just being static points of light, these distant galaxies are teeming with activity. Some are still in the process of formation, while others have long since evolved, their stars burning brightly or even nearing the end of their life cycles. Webb's unparalleled ability to capture the faintest details allows us to see galaxies as they were eons ago. Early galaxies, full of gas and star-forming regions, their structures evolving in real time. But Webb's mission isn't just about observing the past. It's also about revealing the present and the future. By understanding the formation of these ancient galaxies, we can gain insights into how galaxies today continue to evolve. How do they grow and merge? And how do these processes lead to the creation of the structures we see in our own universe? And ultimately, what does this tell us about our place in it? We are only at the beginning of this cosmic journey. Webb's mission is a multi-generational endeavor, one that will yield discoveries for decades to come. As it uncovers more about the universe's birth, it also asks us to consider our own future in the cosmos. What is our place in this vast universe? How do we come to be? And how will we continue to evolve, just as the galaxies around us have done for billions of years? Every new image, every new piece of data from Webb adds to our understanding of not only the cosmos but also ourselves. As we look to the stars, we are not just observing distant points of light. We are looking into the very heart of creation, at the beginning of time itself. With Webb, the universe has opened a new chapter, and we, as its curious explorers, are just beginning to read. The universe is vast, and we are but one small part of its immense story. But with Webb, we have a powerful tool that brings us closer to the beginning, to the birth of galaxies, and to the very heart of creation. The journey ahead is one of discovery, of awe, and of wonder. And with every new revelation, we are reminded of the incredible adventure that lies ahead, not just in space, but in our own understanding of who we are, where we come from, and where we are going.